Good morning. Last lecture we have seen the algorithm of graphical solution of linear programming problem and solve the graphical solution of linear programming problem. In this lecture we have seen the some definition of graphical solution. That is, first definition is slack variable. That is a non-negativity variable which convert less than type constraint of a linear programming problem into the equation is called slack variable. Such as a variable is add to left hand side of less than type constraint, that is its imbalance type less than type, and we have convert to add left hand side and we have equal to the constraint. That is, if example x2 x1 plus x2 less than 600, that is problem is less than type, and that is we add left hand side, that is 2x1 plus x1 plus s1, that is slack variable. We have add left hand side slack variable and we have convert the constant equal to type, that is 2x1 plus x2 plus s equal to 600. Next definition, surplus variable, a non-negativity variable which convert greater than type constraint of a linear programming problem into the equation is called a surplus variable, and such a variable subtract from the left hand side of greater than type constraint. That is example 2x1 plus 3x2 greater than equal to 900, and here we have subtract the right hand side, that is 2x1 plus 3x2 minus s equal to 900, and this is surplus variable. Next definition is the set of value of decision variable, that is xj and j equal to 1 to n, that satisfies the constraint of an linear programming problem is set to the constitution of the solution to the linear programming problem. Feasible solution, the set of value of decision variable xj, j equal to 1 to n, and that satisfies all constraint and non-negativity condition of an linear programming problem simultaneously is set to the constitute the feasible solution to the linear programming problem. And infeasible solution, the set of a value of decision variable xj, j equal to 1 to up to n, that do not satisfy all constraint and non-negativity condition of an linear programming problem simultaneously is said to constitute the infeasible solution to that linear programming problem. And basic solution, for a set of m simultaneously equation in n variable and n greater than m, a solution obtained by setting n minus n variable equal to 0 and following the remaining m equation is m variable is called a feasible solution. And the n minus n variable whose value did not appear in the solution are called non-basic variable, and the remaining m variable are called basic variable. Next, basic feasible solution. A feasible solution to an linear programming problem which is also basic solution is called the basic solution, feasible solution, that is the all basic variable assume the non-negative value. And basic feasible solution are two types, that is first degenerate and second is non-degenerate. Generate solution is a basic feasible solution is called degenerate if the value of at least one variable is 0, and non-degenerate solution, a feasible solution, is called a non-degenerate if the value of all m basic variable are non-zero and positive. That is, degenerate is the basic variable solution is called degenerate if the value of the at least one basic variable is 0 and non-degenerate is all value all value of m basic variable are non-zero and positive. Next definition is optimum basic feasible solution. A basic feasible solution that optimize, maximize or minimize the objective function value of a given linear programming problem is called an optimal basic feasible solution. Unbounded solution, a solution that can identify the increase or decrease the value of the objective function of the linear programming problem is called an unbounded solution. And next definition is graphical solution method of linear programming problem, that is extreme point solution. And last lecture we have seen the step following the step of the graphical solution method of linear programming problem.